morning, students. In the last chapter you have learned the different hardware components of a computer system. So what were those hardware components? The hardware was the physical component of a computer system. Physical in the sense that the user who is operating the hardware of a computer is able to touch it and feel it. That is why they are known as the physical components of a computer system. Examples of such hardware components were the central processing unit, in short CPU, the monitor, the keyboard, the mouse, the printer, etc. Now today I am going to start a new chapter, which is chapter number 2 in your book, and the name of the chapter is Introduction to Computer Software. So what is a computer software? Now unlike the hardware components which can be physically touched by the user with their hand to operate the computer, the software are not the physical components of a computer system. That is, they cannot be physically touched. So the software is a set of instructions that a computer is able to execute or process. Now the question is, who is giving those instructions? We, the users who will be operating the computer system, will give such instructions to the computer. The instructions can be in the form of, say, opening a Word application so that a document can be typed, or opening a Paint application so that a particular image can be drawn on it, or opening a video editing application so that a movie can be edited. Instructions can also be in the form of a message asking the computer to shut down, or telling it to print some documents using a printer, and etc. And instructions can be in many different formats. These are just the few ones that I have told. Now, a computer hardware is a dumb object. It cannot do any activity on its own without the user's interference. That means unless the user gives some specific instructions to the computer will not be able to perform any activity on its own. And that is the reason why hardware is of no use without a software. Without software, a computer is just a machine without any utility. The software written for a specific purpose or to solve a specific problem is called a program. Computer programs are also referred to as computer applications. For example, programs written for playing game and drawing pictures on the computer are referred to as gaming and graphical applications respectively. The softwares are of two types. Those are the system software and the application software. So let's start with the system software. What are those system softwares? The system software are those software which operates the internal components of a computer system. In short, we can say that system software interacts with the hardware directly. As a result, these system softwares are responsible for the functioning of internal components of a computer system. The system softwares are again classified into the following types. The first is the operating system, then the device drivers, then the utility softwares, and at the end there is the language processors. Let's start with the first system software, which is the operating system. Operating systems are the heart and soul of computers. A computer cannot function without an operating system. For a user to give instructions to the computer to execute a particular task, he needs a particular interface, and that interface, which exists between the user and the computer, is known as the operating system. So, an operating system works as an interface between the computer and the user. The user interface provided by the operating system may be of two types. They can be of the text-based user interface, or they can even be of the graphical-based user interface. I will explain you elaborately about these two types of interfaces, that is text-based and graphical-based user interfaces, from the next slide. In the text-based user interface, the user executes the instructions by typing the commands at the command prompt. These commands in the form of instructions reaches the operating system, and then this operating system interprets the command and forwards it to the microprocessor for the final execution. That means, to put it simply, the user first gives the instructions to the operating system in the form of commands, and then the operating system interprets these commands and then it forwards it to the microprocessor for the final execution. But in order to work with such operating systems having text-based user interfaces, the user must remember the commands along with its syntax. The syntax is just a way to remember the commands. The syntax is the way to type the commands. An example of such text-based operating system is the DOS, whose full form is Disk Operating System. The second type of interface is the graphical user interface. Now, in case of operating systems with graphical user interfaces, the user need not remember the commands as in the text-based interfaces. This is because in the graphical user interfaces, it provides menu-based, easy-to-use interface that enables user to operate the computer very easily. An example of such graphical user-based operating system is the Windows XP and Windows 7. There are 5 different functions of operating systems. Those are user interface and command execution, followed by device management, the memory management, the disk management, and finally the application management. I will teach elaborately all these types of functions of operating system in detail from the next slide. Let's start with the first function of operating system, which is the user interface and the command execution. As we already know that an operating system acts as an interface between the user and the computer, so the operating system is actually the platform between the user and the computer, which helps the user submit certain instructions in the form of commands to the operating system, which in turn then retransmits them to the CPU or the central processing unit for further execution. To put it simply, we can say that the operating system acts as a moderator between the user and the computer, which receives the instructions supplied by the user in the form of commands and then retransmits back to the CPU or the central processing unit for further execution. The next function of operating system is device management. The operating system is also responsible for managing the different hardware devices attached to the computer. Be it a keyboard or a mouse, or be it a printer or a scanner, the operating system can manage these hardware devices which will be attached to the computer. Now, any new hardware devices which will be connected to the computer will need a specific driver software. Without that driver software, the new hardware device, even if it is connected to the computer, it won't be able to function it properly. So it is the duty of the operating system that if any new device is connected to a computer, the operating system detects it immediately and looks for its specific device driver software. The next function of the operating system is the memory management. Memory management is another important task which is performed by the operating system. Say for example, if a particular program is being executed by the central processing unit, then the operating system will decide how much memory will need to be utilized by the particular program which is being executed by the CPU or the central processing unit. So it is the duty of the operating system to decide how much memory will need to be utilized by the running program, and it is the operating system which decides that the running program will be loaded in which area of the computer memory. The next function of the operating system is disk management. The operating system manages the hard disks and the secondary storage media which are attached to the computer. Say for example, whenever a new hard disk is being attached to the computer, it will not be able to store any data or files into it. So, for the new hard disk to finally store data or files into it, the operating system should create some partitions known as logical partitions and formats in the new hard disk, so that the new hard disk will be finally able to store data and files. That is why unless the operating system do not create logical partitions and formats in the new hard disk, the new hard disk will not be able to store any data or files. But once the operating system creates the logical partitions and formats in the new hard disk, it will be easily able to store data or files. Now all these times I have been talking about the logical partitions and the formats which are being created by the operating system for the new hard disk. So what do you think are these logical partitions and formats? These logical partitions and formats are actually the logical drives of a computer. Now, if you own your computer and explore it properly, whether it's a laptop or a desktop, just explore your computer properly. Once you explore, you will see that there are different drives denoted by C drive, D drive, E drive or F drive. Those drives are the logical partitions or the logical drives that the operating system creates for this hard disk. The last function of the operating system is application management. The programs that run on a computer are managed by the operating system. If a particular application gets executed by the CPU, some amount of memory need to be utilized for that running application, and that will be allocated by the operating system. But once the application finishes its execution, then the same amount of memory need to be deallocated, and that is also done by the operating system. So in short, the operating system allocates the required memory to run the application and again deallocates the same when the application is closed. The different types of operating systems are: the first one is the client operating system, followed by the server or the multi-user operating system, followed by the real-time operating system. Then we have the distributed operating system, then the multitasking operating system, and then finally the multi-programming operating system. Let's start with the client operating systems. The client operating systems are the most simple and the low-cost operating systems. That means these types of operating systems are very cheap. People can afford such types of operating systems very easily. Since only one user can work at a time in such types of operating systems, so these client operating systems are known as single user operating systems. Examples of such operating systems are Windows 7 and Windows 8. The second type of operating systems is the server or the multi-user operating system. Now before I explain you the server or multi-user operating system, let me explain you what a server is. The server is a computer at a remote location, or it can also be a centralized computer where all the computers will be connected to it. And those computers which are connected to the server are known as the client computers. Certain jobs will be handed over to the server computer by the client computer for processing. If several such client computers gets connected to one server computer, then the client computer will request the server computer connected to it for processing its job request. And once the server computer finishes processing the job request sent by the client, it serves the purpose of the client machine to which it is connected. So as the name server or the multi-user operating system, it defines a computer whose resources which are available can be accessed by more than one user at a time. So to put it simply, multiple users can operate such types of server or multi-user operating system at a particular time. These types of operating systems are also more complex and highly priced. Examples of such operating systems are the Windows 2012 server, the Unix, and the Solaris. The next type of operating system is the real-time operating system. These real-time operating systems are very fast and can produce output in real time. Such operating systems are used in very sophisticated applications like the airline's traffic management, the numerical analysis, and the weather forecasting. Say for example, if you wish to book an airline ticket to a particular place at a particular date, then in such cases, the software should be able to give you accurate data at a prior time. So in such cases, real-time operating systems help in giving out the accurate data to the customers booking an air ticket. The same applies to weather forecasting as well. If you wish to forecast a 14-day period weather data in advance, you need to use real-time operating systems for that, because only that can give you the accurate data in real time. The next type of operating system is the distributed operating system. The distributed operating systems, as the name implies, it is that operating system which can be distributed on more than one physical computers installed at different demographic areas. Say for example, if you have 7 computers connected in different areas of a particular city, and then they form a network of 7 computers, then one particular operating system can be distributed in each of these 7 computers which are connected with each other. And once the operating system gets distributed in each of these connected computer system, it becomes a distributed operating system. The distributed operating systems are generally found in computers which are connected in a network, as in this case where 7 computers have been connected in different areas of a particular city, as I have explained. So distributed operating systems are very much beneficial for us, as we do not have to take the extra burden of installing the operating systems separately in all of these 7 computers connected in a network. Since these computers form a network, only one operating system can be installed, which is then distributed in each of these computers connected in the network. As a result, it eliminates the tedious job of separately installing the operating system in each of the systems. The next type of operating system is the multitasking operating system. Multitasking, as the name implies, multiple tasks can be done at a time. This shows that multitasking operating systems are capable of performing more than one task at a time. For example, A user who is logged into a multitasking operating system can save a file while the other users are just reading it. The last type of operating system is the multi-programming operating system. In these types of multi-programming operating system, more than one programs can execute simultaneously. For example, if paintbrush application and word processor application are two different programs, then both these programs, that is paintbrush application and word processing application, can work and execute simultaneously. Now the new topic that I am going to discuss now is the task or process management. Now, if a particular application is being executed by the CPU, then certain series of actions are being performed by the running application. And these sets of actions which are being performed by the running application are treated as tasks or processes. For example, if you have opened the paintbrush application and drawn a picture, after that you may wish to save that file on a hard disk. The saving of file on the hard disk is a task. At a time, there can be more than one task running on a computer, and the operating system is responsible for coordinating and scheduling them. You can see the list of applications and tasks running on a computer in the Task Manager window. In the next slide, I will show you how the Task Manager looks like graphically.